Hello everyone and welcome to this lightning talk where I will show you this application that I use in a daily basis in my office. It's an electronic medical records, a software that helps doctors organize, store and retrieve patients' information like medical history and conditions, prescriptions, invoices and many other things. First we will see a typical workflow and then we will talk a little bit about code. These are the most recent patients. Let's take an appointment for tomorrow. Appointments can have a type. Let's put X-rays, and these types are totally customizable. We can add anything we want, just like this, and change the color. Okay, now let's say that the patient arrived. It is listed here in the waiting room. We click to open it. We create a new appointment. We write some medical complicated terms and some conclusion. Now, prescription, everything is very simple. It's all auto-completed and the application will store and remember all drugs used by the user, or you can search in our national drugs database for some medications, like this for example. Click and insert. 3 months, okay. After that you can print with one click. You can select the printer, the paper size, and here it is. It generates a PDF that you can directly print. Now, after that, the patient must pay the prestation. So you have here invoices types that are also customizable. Let's add, for example, this polygraphy 8,000 dinar. Now we just check polygraphy, but let's say that patient didn't have enough money. This is the price and this is what the patient gave you today. So it is displayed that there is a lack in money. How can I say this? Sorry. So let's go back to the waiting room. As you can see, this button has updated. Remember this button, we will see it in the coding section. If we click, you have here invoices listed. If you click on an invoice, you have what patient gave you and what is remaining. Let's say that he made another payment of 2,000. We have 2 payments for 1 invoice and 2,000 remaining. From here you can add another payment, another invoice, and look at this button. It's the same as here. It's the same widget, it's the same custom widget we will see in coding section. Last, I want to show you this stats tab that displays many interesting statistics about office activity. You have to select a period, let's say just today. Okay, here is our patient, he came today. Here are the 2 payments, and here is the invoice and what remains to be paid. Okay, now let's go to code. Sorry, here we are. In this application, I use an all widgets approach. It means that every piece of user interface is put in a custom widget. This is for better encapsulation and code organization and cleanness. And this is for reusing widgets in different parts of the application as I showed you with the button. Here is the button that I was talking about. It's a facture button. And here is the list of invoices. Each item in this list is also a custom widget. It's a facture item. And if you remember in the patient's invoices listing, this item in the list is the same widget as this item in this dialog. reusability, and simplicity. When you click on an invoice, you have the payments. Each each item here is also a custom widget. Here, it's a factual add widget, custom widget, with a helper function to directly display it inside this dialog. This button, of course, is the same factual button as we saw earlier. And each line here is a custom widget. It's a factual add item. Now in the stats tab, the list, all this widget list is a custom widget. Here it is. It's a stats comptability, and it's the same widget that is used for receipt payments and facture invoices. You just set this type flag to either type receipt or type facture, and the widget will adapt its behavior and displaying to the situation. Each item is, of course, a custom widget. It's a stat conta list item. This is just a VBox, a fine container VBox, but with a padding of 0. Even inside each list item, this is a custom item. It's a stat conta list item header, and every line here is also a stats conta list item detail. With this approach, code is clean, and each widget is encapsulated and is autonomous. It can work all alone. It accesses database, it displays information. You just have to initialize it with the right data. And it communicates with other widgets, just like standard Fine widgets with methods and callbacks. We try to never access directly inside the widgets variables. That's all from me. Thanks for watching, and thanks for the opportunity to present you my work, and goodbye.
Hello, my name's Michelle Williams. I'm so sorry not to be with you in person today, but I'm delighted to be talking about my project using Fyne and Fission to make a medical calculator app. This app is to do with lung cancer. Lung cancer is a common cause of cancer deaths around the world, and smoking is the leading cause of lung cancer, responsible for about 85% of all lung cancers. Lung nodules are small clumps of cells in the lungs. They're actually quite common, and in many cases perfectly benign, don't cause any problems at all. But some of them need follow-up, and some of them might be cancer. And so in my day-to-day life as a radiologist, I spend a lot of time looking at lung nodules and measuring lung nodules. The size of them and how size changes over time is really important. And we have a metric called the volume doubling time. It assesses how quickly a lung nodule is growing. If it's growing very, very fast, it's more likely to be benign, maybe something like an infection. If it's growing very, very slowly, it's again more likely to be something benign, something that's been there a long time and less likely to be cancer. So volume doubling times in the middle are very important for us to identify. And we've got a formula, some mathematics that we can do to calculate this. But I have a problem. The problem is the software at my hospital frequently doesn't actually work in terms of the volumes not being calculated or the volume doubling time not being calculated. I've also got an app that works on my phone from the British Thoracic Society, which is great, but it only works on iPhone and only calculates volume doubling times in certain ranges. I want to be able to do it on any system, anywhere I'm working, and to work out volume doubling times across the whole range of sizes. So the aim of this project was to develop a simple app to calculate volume doubling time from 2 sizes at 2 time points, and to have this displayed on my app rapidly. So for this, I'm using Fission, which is from FyneLabs. You can sign up to download it here. And this is what happens when we start using Fission. So first of all, I'm going to load up a template. There's a variety of templates available and a variety of themes available at the moment. And I'm going to start with the BMI calculator and the pastel theme. I'm going to put in the name of my app, volume doubling time, and then create the basic template of my app. So this template is based on calculating BMI. We've got some different themes already inbuilt here. I'm going to adjust the color of the text in the light theme so that it's a bit darker and easier to see, but most of the time I use the dark theme anyway. I'm going to change the text at the top to say what the app is, make it bold, justified to the center of the screen. And then in the container of the whole app, I'm going to add another label. In the tree down the side, I can move this label. I'm going to move it up a bit. And this is going to say what the first set of measurements are. Oh, a bit too high. There we go. So this is going to have a little bit of disclaimer text in it. Obviously, this isn't a medically certified app, should only be used by trained professionals and shouldn't be relied on for clinical care. As you can see, this text is extending outside the boundary of my app. So once I've changed and sorted the spelling, I'm going to select word wrap so that this wraps into a box the size of the app. I'm now going to create another label. And this label is going to say what the measurements are. So these are the first set of size measurements. And I'm going to have a measurement, the volume, and I also want the date that this was created. So this is volume 1, and I'm going to change the kilograms to millimeters cubed because that's the units of measurement. And I'm going to change this label from weight to x1, and I'm going to use that in the maths that I'm going to calculate a bit later. So that's volume 1, this is date 1, and I'm going to remove that entry widget, and instead I'm going to add a date entry widget. Now, when we run the app, you're going to see that this lets me select a date, month and day in a very nice, easy way. So that's the layout of the first set of measurements. Now I need to do the same again for the second set of measurements. So I'm going to start with a label with the size of the second nodule. Sorry, the second size of the nodule. And then I'm going to add a container. So my widgets are going to be within containers. I'm going to have a container with 2 containers within it. So that's one container. And this first container is going to contain the label for the volume and the label for date as well. It's going to be a border container with a VBox container within it. So those labels are orientated vertically one on top of the other. So this is volume 2 and the label for date 2. We'll just change that first date text label to date 1 while we're at it. Now I'm going to create the second container, and this is going to have within it the measurement and the date. So it's going to have an entry for the measurement and a date entry for the date. So just like the ones above, I'm going to have some example text, example of a slightly larger increase in size of the nodule, and I'm going to make the ID X2. And the date, I'm going to have the ID of T2. So this is going to be a VBox again, and then the overall container is going to be left aligned so that they nicely line up like the ones above. Make those bold so that they look the same, and then I need to move that calculate button down to be beneath the container. So the final thing I need is the label where I'm going to put the results. So I'm going to insert a label and I'm going to give it the ID out for our output, and I'm going to make it blank to begin with. There's no holding text there. Now let's just review everything we've got. We've got X1, which is our first measurement, X2, which is our second measurement, two dates labeled T2 and T1. The calculate app is linked up to the calculate function already, and we can go to main.go and adjust that calculate function. So I'm going to add in an import for math, which we're going to use here, and then copy in the function that we've created based on the formula I showed you earlier. And then I can click on the run button, and the app will be building. Now the run and install are there because I've got developer tools switched on, and you can see now the app running. We can put in a volume, a date, a second volume that's a bit larger, and a second date that's later in time, and we can click on calculate, and it's calculating their volume doubling time of 98 days, which is very fast but reassuring, suggests a benign etiology. So this is very useful for me in my day-to-day clinical practice. So a couple of other things on the Fission screen here. You'll see up at the top right, we've also got preview, where you can preview your app, just the UI of the app, and deploy, where you can send it to Jeffrey. So if I click that deploy button, it sends it to Jeffrey, the build server. You can see it building, and then I can download that app to use on my computer wherever I happen to be working, in whatever operating system I want. So thank you very much. That's a whistle-stop tour of something that's really useful to me and hopefully useful to you.
Hi, welcome to my talk on interesting packaging stuff with Fyne. All the slides for the talk are at this GitHub link. Please do download them and have a look if you're interested. I will be flying through this, as a lightning talk should be. My name is Nick White. Let's get started. So here's the contents. I'll be covering Rescribe, which is the OCR tool I developed, and which all of the tricks I'm talking about are applied in. We'll go into creating a universal binary for Mac, embedding some native binaries inside the Go binary that you create, Linux packaging with Flatpak, and a word on some graceful fallbacks it's worth taking into account. A caveat, I haven't used FyneCross, which seems mad given that I'm talking about cross-compiling and packaging and stuff. It looks very good. It wasn't a thing I was aware of when I did my initial development work, so there could be some overlap. Anyway, let's go. Rescribe. So it's a piece of OCR software. The GUI is in Fyne. This is the GitHub address for it. If you're interested in looking, the command/rescribe directory has all the interesting stuff from the perspective of Fyne and packaging and stuff, including a makefile. Okay, creating a universal binary for Mac. So you probably know newish Mac laptops have ARM chips rather than Intel chips, M1, M2, etc. Obviously these are different architectures, so you need to build them differently. However, Mac has a concept of a universal binary, which is essentially just a binary which glues the two together with a bit of metadata. You can create that quite straightforwardly if you create a binary for each with Go build, as I show here. You can then use a tool called LiPo, which is available on OS X Cross, or through Xcode on Mac if you have a Mac. That will then combine the two together in a format that Mac can read. Then once you've done that, you can use the Fyne package to create the .app as normal, and you can use CodeSign to sign it. Signing it is helpful for reducing the amount of scary messages that Mac will show at you. Code sign, as far as I know, you can only get it to work on the Mac. Maybe possible otherwise, probably a pain in the ass. This is how you get that to work. You basically create a certificate of type code signing, and then you pass it to the code sign command I showed at the bottom there. Okay, embedding native binaries, next thing. So the Rescribe tool uses a C++ program called Tesseract to do a lot of the heavy lifting. This obviously is not built with Go, so it is more of a pain in the ass to get different architectures out of and to link in. But I still wanted to have one binary which contained everything that was needed. So you can do this with Go embed, which essentially just stuffs a whole bunch of whatever you want into your finished binary. And then, so each Tesseract binary plus any libraries it needs, you can stuff into a zip, embed that using build constraints to embed the right version for whatever you're building, or none if you're not building something which there is a pre-done version for. Then you can just unzip that within the program into a temporary directory, run it, and nobody is any the wiser. Malware authors also do this, I believe. It's also nice practice to be able to use Go generate to download those zips, because you probably don't want them in your repository. That would be mad. You can do that by creating a little package which you go build ignore pragma. That's how you do that. It's nice. So dynamically compiled binaries, so ones which use external libraries, can be hard to make portable. On Windows it's quite easy, as long as you find all the DLLs that are needed and put them in the same directory as the executable. That's where Windows will look first, so that'll work. With Linux, it's often easy to just build something statically. Thanks, Linux. With Mac, it's a pain in the arse. This is the procedure. Essentially, you need to find all the dynamic libraries it uses. So you need to run otool-l on the executable and on all of the libraries and on any libraries they reference and so on. And then use this install main tool to change the path they're looking for to one with this @executable path, and then reassign those executables and libraries, and then it'll work. And obviously you need to do that for ARM and Intel if you're doing both of those. Maybe there's an easy way, let me know if so. Linux packaging with Flatpak. So there are lots of different ways of packaging things for Linux. Flatpak is a nice one which works on pretty much all distributions. Basically you create a YAML file which describes how to build it. The build environment doesn't have access to the internet though, so one thing you need to do is just use Go mod vendor to stash all of the modules that any particular version uses, and then add them as a source. So they're pre-downloaded into the build environment. Then it will work nicely. There are some good build tags that Fyne makes available. There's a Flatpak one, excuse me, which enables desktop portals, which gives you a nice native file picker and improves sandboxing. There's a Wayland tag, which enables Wayland rendering, which is what modern Linux systems use rather than X11, but not all systems support it. So again, you can build both versions and create a launcher script that picks one. Thanks a lot to Jacob Alzin for his work on this stuff. He's made it much nicer in Linux. This is roughly what the YAML looks like for that. Quite straightforward. You can see it combining or giving two different binaries and a launcher script. Graceful fallbacks, the last thing to mention. It's nice to make sure that find, get and go run work well. So use build tags to do anything fancy like embedding, so that a default run doesn't need anything but what's in the repository, and you should be all good. The end. Please email me. Sorry I can't be here today. I hope you really enjoy the conference, and goodbye.